All right. Good evening. You're welcome to today's lecture. Today, we'll take a look at mathematics. All right. So, okay. Okay. Today we see if we are going to look at reviews of some certain little things that matters in mathematics. So that's where we are going to kick off. We're going to review some little things that matter in mathematics. And one of the things I want us to look at today, we'll look at integers. We have a review of integers, basic operations of integers. Before we go into what an integer is, okay, let's look at it. What is an integer? What is an integer? Some people will tell you that integers are whole numbers. No, integers are not actually whole numbers. Whole numbers are part of integers. Now, for you to understand integer, you must understand the number line. For you to understand integer, you must know what number line is. You know that number lines start from negative infinity to positive infinity, and in between is what? Zero. So let's assume positive if negative infinity means that we don't even know where the negative sign starts. But due to the length of this line, I can simply say start from -4, -3, -2, -1 and 0. And 1, 2, 3, 4 to positive what? Infinity. This is what we call number line. -4 is less than -3. -3 is less than -2, less than -1, less than 0. 0 is less than 1, and what have you. This is the negative side, and this is the positive side. These numbers, this concrete point you are looking at, this concrete point, numbers -4, -3, -2, -1, 0, 1, 2, 3, 4. You're looking at are what we call integers. They are what we call integers. All these concrete numbers, -3, 4, -3, -2, -1, 0, 1, 2, 3, 4. They are called what? Integers. Now, the ones that have negative sign are the negative integers. 0 is there. Then this one are the positive integers. Now, in between these integers, we have a lot of numbers. Between this -4 and -3, a lot of numbers are here. And these numbers are continuous. They are not concrete. You start seeing fractions, 1/3, continuous fraction, 1/3, 1/2 is here, half is here. Pi is 3.14. Pi lies here. Is a continuous number, irrational in that sense. So in between these numbers, these concrete numbers, these integers, a lot of numbers are here. But my focus is just integers. That's the focus of this topic. If we make our time to go into numbers full time, we discuss numbers, then we can now start discussing all those numbers. But for now, my focus is what? Integers. Integers. So integers start from negative infinity. So integers are actually concrete points on the number line that stretch from negative infinity to positive infinity. So all these things you are seeing here are what? Integers. Now, but from here up, have their own names. Here, 1, 2, 3, 4, 5. These ones are called natural numbers. Natural. I said I'm not going into number. Yes? These are natural numbers. From 1, they are the counting numbers we know. They are the counting numbers. Why I mentioned it is because they are under integers. They are also integers. Then why whole numbers? Whole numbers start from here to positive what? Infinities. So all this is an integer, yes?
I cannot see the board clearly.
You cannot see the board clearly.
I'm not seeing the board. The other side from 1 to infinity.
Is it that it's not clear at all, or is it from your side? Let me understand.
I'm not seeing it. I'm not seeing it.
Okay, let me change the marker. This is from the marker.
It's not the marker, from the camera.
There's nothing I can do about it. So at this point, I cannot do anything about it. Maybe it's from the illumination. Can I see it now?
No. I'm seeing from -4 to 1.
What will be the cause?
Maybe where you place the camera.
Wait, let me write it again. Let me check something.
Okay.
You said it's from where to where?
I'm seeing from -4 to 1.
Can I see it now? Can I see it now? Can I see it now, Judy? Are you there? Can you see it now?
It's from your camera.
Okay, you see cannot see it.
Like where you place the camera, I cannot see the other side of the board. It's okay.
You can see it now.
Yes.
Okay, thank God. All right, let's continue. But you can hear me clearly, right?
Yes.
Okay. So I said that if you want to treat about numbers, so start going deep. But why I mention this is that why I mention natural numbers and whole numbers is that sometimes people confuse integers. People, if you ask people to define integers, they'll say that integers are whole numbers. No, they are not actually whole numbers. Whole numbers are part of integers. Not all integers are whole numbers, but all whole numbers are what? Integers. Not all integers are whole numbers, but all whole numbers are what? Integers. From here, from -1 to the negative infinity, they are not whole numbers, but they are integers. But from this here to this positive infinity are whole numbers. While from 1 to positive infinity are natural numbers, counting numbers. So this is what integer is all about. So if you are asked to define integer, don't say that integers are whole numbers. No. Integers are simply concrete points on the number line that stretches from the negative infinity towards positive infinity. You can call it concrete numbers or points. Once you mention number lines and say concrete points, we all know we are talking about what? Numbers. Is that clear? Is that clear?
Yes.
So this is a way of definition, trying to say what integers. So now let us go straight to what I want to talk about. Some basic operations. Other operations in integers are simple operations. Addition, subtraction, multiplication, division. These things are what we've been doing from primary school. So I wouldn't want to waste our time there. But there are something I want to point out in the division before we move on. Maybe I'll give you one or two things to solve here before we go. But before that, there's a very important point I want to make. You know, sometimes you may see a question that may want to test your knowledge of division. They will say they will want to test if a particular number can divide a particular number. So this will take us to what we call divisibility test. Divisibility test. Divisibility test. What do I mean by divisibility test? It just a set of rules to determine whether a number is divisible by another number. Set of rules that is used to test or to determine if a particular number is divisible by what? Another number. Set of rules for determining that. Now, so we are going to look at this set of rules. Is that clear? So that's what we want to talk about. Of course, if we say 0, anything divided by 0 is 0. So we're not going to waste our time then. And anything divided by any number divided by 1 is still that same number. So let's start from 2. To determine if a number is divisible by 2. When I mean divisible, I mean if you can divide it without remainder. So let's look at 2. We are looking at the rules now. A number, to determine if a number is divisible by 2, what you check out from that number to say that number can be divided by 2 is look at the last digit of that number. If the last digit of that number is even number or 0, if the last digit is even or 0, when we say even, we mean that the last digit can be divided by 2. So if the last digit of that number is even number or 0, that number must be divided, definitely be divided by what? 2. That number is divisible by 2. If you see something like 2,000, no matter the number of digits, 2,242. Once the last digit is 2 or 4 or 6 or 8, even number, that number is divisible by 2. Or if the last digit is 0, either 0 or even number, the last digit, that number is divisible by 2. You don't even need to do anything. You just think. Sometimes such can form an OBJ question to test your knowledge of what? The division. So any number that ends, the last digit is 2 or 0, that number is, even or 0, that number is divisible by 2. Is that clear? Then let's look at 3. Let's look at what we see in a number for you to say that that number is divisible by 3. Did you understand what I said by 2? A number that can
Yes.
be. Yeah?
Yes. Yes.
Right. Now, for a number to be divisible by 3, look at that number. Look at the digit of, check all the digits of that number. If you add all the digits in that number, and the sum is divisible by 3, that number is divisible by, can be divided by what? 3. If you see a number and you look at the digit of that number, and that digits, if you sum all the digits in that number, and if their sum, the sum of all the digits is divisible by 3, that number is divisible by 3. Something like C27. C27. 2 plus 7 is what? 9. 2 plus 7 is 9. 9 divided by 3 is what? 3. So 9 is divisible by 3. So 27 is divisible by 3. 27 is what? Divisible by 3. Let's check another number. Okay, let's look at let's look at 2, 1, 6. 216. Let's check whether this rule is true with 216. Let's check. 2 plus 1 is what? 3. Plus 6, 9. 9 divided by 3 is 3. So by this rule, 216 is divisible by 3. Is it true? Look at number. It's even obvious, because 3 divided 21 is what? 7. 3 divided 6 is what? 2. So it's divisible. So you can test other numbers and to check whether it's true. So what it means that if for a number to be divisible by 3, all the digits of that number should be able to give you the sum of the digits of that numbers should be divisible by what? 3. All right, let's look at 4. A number that you look at straight, you'll be able to say that yes, this number is divisible by 4. Now, if you see a number, look at the last 2 digits of that number. The last 2 digits of that number. If a number formed, not the sum, if a number formed by the last 2 digits of a number is divisible by 4, that number will be divisible by what? 4. See what I mean? Two zero eight. 208. What are the last two digits of this number? Huh?
What?
Hello? What are the
Hello.
last what are the last two digits of 208?
0 and 8.
Now, number that can be formed, number formed by 0 and 8 is simply 8. Hope you know.
Yes.
Is 8 divisible by 4?
Yes.
That means 208 is divisible by 4. It's even clear, said. Look at it. 4 divided 20 is what? 5. 4 divided 8 is what? 2. Let me check more complex number. 2, 1, 2, 1, 2. Last two digits is 1 and 2. So 12. Let's check whether this one is true. 12. So the number formed by last two digits of 212 is what? 12. Is 12 divisible by 4? Yes, 12 divided by 4 is 3. Let's check whether it's true. It's a rule. So we are testing it to be sure that it's true. 212. Is 212 divisible by 4? Let's do it straight and to confirm. 4 divided 21 is what? 4 divided 21 is 5, right? 5 remainder 1. You multiply it by the base. You remember this is base 10. Everything here is a base 10. You multiply by the base, which is 10. 10 times 1 is 10. 10 plus this 2 is 12. 4 divided 12 is what? 3. 4 divided 12 is what? 3. Are you with me?
Yes.
So that means 212 is divisible by what? 4. Now let's look at another number. Let's work with 5. How do you know a number that is divisible by 5? By just looking at it without even solving it. If you see a number and that number ends in 0 or 5, once a number ends in 0 or 5, that number is divisible by what? 5. 0 or 5. That number is what? Divisible by 5. There are many of them. 2,000 is divisible by 5. 2,005 is divisible by 5. 255 is divisible by 5. 2,460 divisible by 5. Because everything anything that enters here now must be divided by 5 because of this 0. The same thing, anything that enters here now must be divided by 5 because of this 5. So this one is straight forward. So we don't have to waste our time on this one. Is what? Straight forward. Unless you have any question to ask them, but it's straight forward. Now let's look at 6. Let's look at 6. Now, if you see a number, and then that number, the number itself is divisible by 2 and 3. Once a number is divisible by 2 and 3, that number will definitely be divisible by 6. So once a number is divisible by 2 and 3, that number will definitely be divisible by 6. So that one is non-negotiable. That one is for non-negotiable because even 2 and 3 are factors of 6. So that one is not negotiable. Once that number can be divisible by 2 or 3, that number will certainly be divisible by 6. Now let's go to the next 7. For 7, no rule. This one, no straight rule for this one for now. Two of us can do more research on that. We can come up with something. Yes, because those people that discover this are human beings like us. So we can still come up with something there. But for now, no room for now. So I'll keep this aside. 8. 8. How do you determine if a number is divisible by 8? If you look at the number, if you see any number, check the last 3 digits. If the last 3 digits of that number, anyway, depending on the number of digits in that number anyway. But you just know that at least the last 3 digits of that number at most, if the last 3 digits of the number is divisible by 8, once up to last 3 digits is divisible by 8, that number will be divisible by what? 8. That number will be what? Divisible by 8. Now 9. How do you know 9? If the sum of the digits, if you see a number now, the sum of all the digits of that number, if the sum of the digits in that number is divisible by 3 and 9. What I mean is this: if you are given a number, add all the digits in that number. Whatever answer it gives you, if that number it gives you is divisible by 3 and 9, that number is definitely divisible by what? 9. Let's check whether it's true. 2 27. 2 plus 7 is what? 9. 9 is divisible by 3. 9 is also divisible by 9. So 27 is divisible by what? 9. Because 27 divided by 9 is 3. Let's see 81. 81. 8 plus 1 is 9. 9 divided by 9 is 1. 9 divided by 3 is 3. So 81 is divisible by what? 9. So these are the simple tests you can do to test if a number is divisible by another number. Let's look at 10. Let's look at 10. Let's look at 10. In fact, 10 is simple. If you look at a number, any number you see, and the last digit is 0. Once the last digit of that number is 0, that number is divisible by 10. Once the last digit is 0, that number is divisible by what? 10. There are many of them. 20, 200, 210, 250. Once the last digit is 0, that number is divisible by 10. Let's look at 11. 11 is a bit complex, but let's look at it. If you see a number There are two things you check out for that number. Either of these two things will tell you whether the number is divisible by 11. You know, let me ask you a question. I'll write a number now. You tell me which of the position is odd position and even position. 1, 2, 3. Sorry. 1, 2, 3, 4. 247, 0. 3,564. In each of these numbers, I want you to tell me which of the digits is in odd position and the one in even position. Let's start from 1,234. Look at these digits. Tell me the one that are in odd position and the one that are in even position. Oh yeah. Start from 1,234. Are you there? Oh, I am in lose. All right, it's okay. Now let's look at it now. 1, 2, 3, 4. This 1 is in odd position. 3 is in odd position. But 2 is in even position. 4 is in even position. This 2 is in odd position. This one is in even position. This is in odd position, even position, odd position, even position, odd position, even position. So based on this now, I will now explain the rule when we are dealing with 11. If you are dealing with 11 now, if you are given a number and you add all the digits in even position, keep the sum. Add all the digits in odd position, keep the sum. First instance, if the sum of all the digits in odd position is equal to the sum of all the digits in even position, that means that that number is divisible by what? 11. The second instance is this. If the difference of the sum of all the number digits in the odd position from the sum of the digits in even position, if their difference is 11 or multiple of 11, that number is divisible by 11. That number is what? Divisible by 11. See what I mean? This one can be confusing, but see what I mean by that. Let me get an example. Look at 2. Let me even. Okay, let's look at 2,400 and 24,739. This 2 is in odd position. 4 is in even position. Odd position, even position, odd position. So let's add all the numbers in even position. We have odd position. 1, 2, plus 7 plus what? 9. This will give us what? 18. Let's add the numbers in even position. 4 plus 3. This will give us what? 7. 18 is not equal to 7. The first instance said that the two of them need to be equal before the number can be divided by 11. But there's a second instance. The difference between them must be 11 or multiple of 11. Let's check. 18 minus 7 is what? 11. So if 18 minus 7 is 11, what it means is that what it means is that this number is divisible by what? 11. That is the meaning. Let's check whether it's true. Let's check whether it's true. 24,739. 24,739 divided by what? 11. Let's go. 11 divided 24 is 2. Remember, this all this here is in base 10. 11 divided by 24. Sorry, 24 divided by 11 is 2. Because you can find 2 11s inside 24. 2 remainder 2. 2 remainder 2. That remainder you multiply by the base you are working on. We are working on base 10. 2 times 10 is 20. You add it to this 7, it becomes 27. You keep dividing by 11. 27 divided by 11 will still give you 2. Because inside 27, we have 2 11s. So 2 remainder 5. Because 22, 11 times 2 is 22 plus 5, 27. So 2 remainder 5. You write 2. Carry that 5. Multiply it by the base you are working on, which is base 10. 5 times 10 is 20. Sorry, 5 times 10 is 50. You add it to this 3. 50 plus 3 is 53. You keep dividing. 53 divided by 11. How many 11 can we find inside 53? You can only find 4 11s for sure. So 53 minus 44 is 9. If I'm not mistaken. Sorry, 53 minus, yes, is 9. Because 54 minus 44 is 10. So 53 minus 44 is 9. So here with 4, remainder 9. 4 remainder 9. Remember, we are working on base 10. You multiply that 9 by the base you are working on. 9 times 10 is 90. You add it to this last digits. 90 plus 9 is 99. You keep dividing. 99 divided by 11 is 9. So this number is divisible by what? 11 without what? Remember. So the 24,739 divided by 11 is what? 2,249. So I can mark this through, but we can still test. You can test other numbers to confirm. But for now, I can mark this rule for 11. Now let us look at some questions, some examples, and we can look at some questions we can solve on this and take it off from there. Okay, let's check if 7168 is divisible by 2, 3, 4, 5, 6, 8, 9, 10, and the what? 11. Let's check. Let's start from 2. Let's start from 2. Remember what we said about 2. Remember that that if a number is divisible by 2, the last digits. So if the last digit of that number is even, is what? Even. Then that number is what? Divisible by 2. Remember, go back to our rules we pointed out to before. Go back to our rule. Go back to our what? Our what? Rule. If the last digit is even or 0, sorry, the number is divisible by 2. Last digit here, this is first digit, second digit, third digit, fourth digit. The last digit is 8. 8 is divisible by 2 because 8 divided by 2 is 4. Remember 0. So this number is divisible by 2. Simple. Just say half of it is no need try to divide it because I know it's divisible by 2. Let's look at 3. For the weaker brethren, let me do it. 1768 by 2. 2 divided 7 is 3. There are 3 2's inside 7. Remember 1. Without 1 times the base they're working on, 1 times 10 is 10. 10 plus 1 is 11. We continue dividing. 11 divided by 2. How many 2's can we find inside 11? We can find 5 2's as whole number because 5 times 2 is 10. So we have 5. Remember what? 11 minus 10 is 1. Remember 11. Sorry, remember 1. You multiply that remainder by the base you're working on, which is 10. 1 times 10 is 10. You add it to this one. 10 plus 6 is 16. 16 divided by 2 is 8. Remember 0. 8 remainder 0. 0, you multiply the remainder, which is 0, by the base you're working on. 0 times 10 is 0. 0 plus 8 is 8. You keep dividing. 8 divided by 2 is 4. So this number is divisible by what? 2. This is just half of this. All right, so let's check 3. Let's check 3. So what did the rule say about 3? What did the rule say about 3? The rule said that if you see a number, add all the digits of that number. If all the digits of that number, if the sum of the digits of that number is divisible by 3, that number is definitely divisible by what? 3. Let's check. Let's add all these digits. 7 plus 1 is 10. 10 plus 6. Sorry, what am I saying? 7 plus 1 is 8. 8 plus 6 is 14. 14 plus 8 is 22. 22 is the sum. Is 22 divisible by 3? No. 22 is not divisible by 3. If you try, since 22 is not divisible by 3, if you try divide by this rule, if you try dividing 7,168 by 3, it will not give you, it will give you a remainder. Let's check whether it's true. 7,168 divided by 3. Let's go. 3 divided 7. How many 3's can we find inside 7? We can find 2. So we have 2. 2 times 3 is 6. 7 minus 6 is 1. So the remainder is what? 1. You multiply the remainder by the base we are working on. 1 times 10 is 10. Plus 1 is 11. You continue dividing. 11 divided by 3. How many 3's can we find inside 11? we can find 3 complete 3 as 3 as a whole number inside 11. 3 times 3 is 9. So 11 minus 9 is 2. So we'll write 3 here. So remainder is 2. You multiply the remainder by the base you are working on. 2 times 10 is 20. You add it to this number here. 20 plus 6 is 26. You continue dividing. 26 divided by 3. How many 3's can we find inside 26? We can find 8 because 3 divided 24 is 8. 3 times 8 is 24. So we can find 8. What is the remainder? 26 minus 24. The remainder is 2. You multiply that 2 by the base you are working on. 2 times 10 is 20. You add it to this 8. It becomes 28. 28 divided by 3. You keep dividing. How many 3's can we find inside 28? You can find 9 because 3 times 9 is 27. So here is 9. What is the remainder? 28 minus 27 is 1. 1. The remainder is 1. So at this point now, decimal point to enter because you have a remainder that because it should actually be 1/3. But let me just put that point because of that 1/3. So that one you multiply by the base you are working on. 1 times 10 is 10. There's nothing here to add. Here is 0. You add 10 to 0, it becomes 0. It becomes 10. 10 divided by 3. How many 3's can we find inside 10? We find 3 3's because 3 times 3 is 9. What is the remainder? 1 again. Multiply by 10. 10. 10 plus 0. 10. Divided by 3. 3. So this number will give you 3, 3, 3, 3. If this is as decimal fraction, if you want to leave it as a common fraction, it becomes 2, 3, 8, 9, 1/3. Because 3 times this will give you a number, add it to 1, it will give you this. Three times this will give you 367. Please check whether 367. Let's check whether 7617 is divisible by 3 for A. Let's add. 7 plus 1 is 8. 8 plus 6 is 14. 14 plus 7 is 21. 21 divided by 3 is 7. So this number is divisible by 3. Multiply this. 27. Carry to put here. 3 times 8 is 24. 24 plus 2 is 6. 26. Put 2 here. 3 times 3 is 9. 9 plus 1 is 11. Put 1. Put 1 here. 3 times 2 is 6. 6 plus 1 is 7. It shock you. So if you add this one now, it becomes 3, 7, 1, 60 divided by 100. So in common fraction, it's like this. 2,389 whole number, 1/3. But as decimal fraction is 1.333. Don't worry, we will still treat decimal fraction and another things. So this is 3768 is not divisible by what? 3. That's what we have established now. 7168 is not divisible by 3. 7168 is not divisible by 3. Let's check whether it's divisible by 4. Let's check if it is divisible by 4. Remember what the rule said for 4. If a number, check the last 2 digits of a number. If a number formed by that last 2 digits is divisible by 4, that means that number is divisible by 4. What are the last 2 digits of this? Is 6 and 8. So number formed from here is 68. Let's check whether 68, if 68 is divisible by 4. Is it possible? This is 1. 1 remainder 2. 2 times 10, 20 with 8. Let's do it here. 4 divided 6 is 1 remainder 2. 2 times 10, 20 plus 8, 28. 28 divided by 4 is what? 7. 7. So, by this rule, since 68 is divisible by 4, that means this number is divisible by what? 4. This number is divisible by 4. That's the meaning. Let's check. 7168 over 4. Let's go. 4 divided 7. You can only find 1 4 in 7. We have 1, remember 3. 7 minus 3, 7, 4 is 3. Multiply 3 by the base you are working on. 3 times 10 is 30. Add it to this one. 30 plus 1 is 31. You keep dividing. 31 divided by 4. How many 4 can we find inside 31? We can find 7 4s. Because 7 times 4 is 28. So we find 7 4s. 28. 31 minus 28 is 3. So the remainder is 3. You multiply the remainder by the base you are working on. 3 times 10 is 30. You add it to this 6. 30 plus 6 is 36. 36 divided by 4 is 9 straight. It's 9. Because 2 times 9 is 18. 18 times 2 is 36. So it's 9. 9 remainder 0. You multiply the 0 by the base you are working on. 0 times 10 is 0. You add 0 to this 8. It's still 8. Sorry for the breaking transmission. Hope you can see the board clearly. They just power just left now. Okay, let's continue. It's clear. So it's 8 because 36 divided by 4 is 9. Remember 0. 0 plus times the base you are working on 10 is 0. 0 plus 8 is 8. Then 8 divided by 4 is 2. Perfect. So this number is divisible by 4. It is divisible by 4, 2, 4, but not divisible by 3. Is it divisible by 5? No. We made it clear that for 5, for a number to be divisible by 5, the number has to be what? The last bit of the number has to be 5 or 0. In our next class, we complete 6, 8, 9, 10, 11. Our time was the last for today. Or better still, I want you to do that of 6, 8, 9, 10, 11, and post your answers on the comment section. Be it in YouTube or Facebook, where you watch this, because my full videos are on my Facebook and YouTube channel. Watch this in there. Try to solve 6, 5, 6, 8, 9, 10, 11. Then comment on then share with us what you answer on the comment section. And God will bless you as you do so. Thank you very much for your attention. See you next time.